So for a while lately, we've been talking about ways you can measure parts of stuff. If you're in math, you get part of something. What's a tool that you can use to measure when you get part of something? Not a tool, but a math tool. A math thing that humans have invented to measure when you got some of something.
Decimals?
Decimals. We've done a lot of stuff lately with decimals. Second choice.
Fractions?
Fractions. We've done a lot of stuff with fractions. For the very first time this year, we're going to do something with the third choice, but I've dropped this choice in a few other days. Percentages. So today, for the first time, we're going to get involved in the world of percentages. So we've spent a fair amount of time turning decimals into fractions, fractions into decimals. Get ready to turn decimals into percents, percents into decimals, percents into fractions, fractions into percents, all that kind of stuff. Does anybody remember anything from previous math classes taught by other teachers in other places about percentages? What do you know? Anybody, anything about the percentages? Anybody at all? Any memories you have? Percentages are always counted out of a certain number. It is 100. Percentages are always out of 100. Why would that kind of connect to maybe other things that we've learned this year that percentages go out of 100? Does that remind you of anything else we've ever talked about?
Decimals?
Maybe.
Fractions?
Maybe. Something about percentages connecting to 100. Anybody have a link to something else that's familiar with? Okay, what is that?
Money?
Yeah, money. How does that remind you of money?
Because like $1 is 100.
Yeah, cents, dollars. There's 100 cents in a dollar. What else does this maybe remind us of?
Measuring like centimeters.
Centimeters. So centimeters have previously had to do with 100. What's the other things maybe this kind of like connects to from our memories? Centuries have 100 years. Or even if you wanted to get off the topic of math and think about bugs.
Centipedes.
Centipedes.
100 legs.
100 legs. I don't know in Spanish where you guys are in your thing. Have you done some numbers in Spanish?
Yes. Yeah.
Is that 100? I don't know Spanish, but yeah, I figured it's going to be a word that looks about like this. Things with C's, those C words, they all tend to have to do with hundreds. So if I tell you we are 33 out of 100, and I want you to tell me a percentage, you can very quickly do that. It'll take about 1 second if we remember how to do it, and if you don't remember, that's why we're here to remind, how can I write this as a percentage?
33%.
Just write 33%. How do I write percent? What's that? What's the symbol?
It's like a slash with 2 dots.
Yeah, it's like a slash. It's with like sort of these little dots that look almost like a degree sign. So we've got 33%. That's the symbol that we want to use. So over here in a second, I'll give you some percentages and ask you to give me back a bunch of fractions. But we'll start off, I'll give you fractions, you give me back a percent. The percent sign is like the money, the cents sign. It always goes on the right. We don't ever put the percent sign before things. So if I throw you 41 over 100, you can quickly just throw me back
41%.
41%. If I throw you 37 over 100 real fast, you just throw me back 37%. Now, most fractions aren't over 100. So another day we'll need to get into what do we want to do if it's like 3/8. How do we make that a percentage? We'll get that another day. Today we're just very lightly introducing the concept of percentages are always out of 100. They'll only give you fractions today that are out of 100. We'll worry about other fractions other days. But that's half the lesson is they give you a fraction, you give them a percent, means it's out of 100. Questions so far? So if I pop over here and go in reverse, if I give you the percentage, you should be able to give me a fraction. Somebody with a hand, what do you think about 37%?
That is
made it more than what it was. It's simpler than that. You go, Quentin.
Real 37 over 100.
Just put 37 over 100. 31%? Just start 31 over 100. 11%.
11% over 100.
11, throw that over 100. 3%. 3 over 100. Always over 100. Every single time over 100, no matter how big or small that number is. 25%?
25.
It's 25 over 100. Let me make up another one just like on the spot. Let me go 150%. If I go 150%,
1 and 50 and 100.
let's go simpler than that just so we don't confuse people. We don't,
1 and 1/2.
simpler, go backtrack. You're doing like 4 steps in your head. Just give me a starter step.
Oh, wait. 150 over 1,000.
One, no,
150 over 100.
go 150 over 100. The moral of the story that I'm trying to emphasize here is we always put the thing over 100 every single time. There's no tens, there's no thousands, there's no anything. Everything always goes over 100 every time, every time. Anything with a percent, put it over 100. That's our deal. Then fractions should always give you hesitation, and we do want to do some of the things people were starting to do, but if we did that from the word go, we're going to lose people if we do multiple steps at once. What is it we should always look to do with fraction answers that sometimes people remember and every once in a while we forget? What am I talking about here? We always want to look to reduce if we can. Now it's not that you always can. So let me say A, B, C, D, E, F. Somebody tell me one of those that yes, we can reduce, so let's go after it.
E, that could be 1/4.
E can be 1/4. Now you could reduce this by dividing 5 into both. You could go 25 into both. There's a couple numbers there that go into both, so we want to divide into both till we get it down to lowest terms. 1/4 is best. Somebody spot me one that does not reduce. It just is what it is, and we're done. Can't be made any better. A. 37 is a prime number. 37 can't go into 100 on its own. Nothing else can go into 37, so that's just as good as it's going to get. Then anybody jump in, either tell me one that's good or one that's bad. It doesn't matter to me which way you take it.
F could be 1.5.
F is going to go down to 1.5. It's improper and it's reducible. We want to break that down. It is 1.5. You did say that at the beginning, but if we came out of the gate and just said, oh, it's 1.5, I think we were going to lose some people. The important priority was always start by putting it over 100, then work. Somebody else weigh in, B, C, D? Good, bad, opinion, somebody?
On C, that could be 1/9, maybe?
Does 11 go evenly into 100?
No.
Okay, so it's good. Nothing can go in, 11 can't go into 100, and 11's a prime, so there's nowhere to go with that one. Anybody else? An opinion? Yeah. D is good, because 3 can't evenly go into 100 on its own, and 3 is another prime. I used a lot of prime numbers today, just so they wouldn't reduce.
B is
B
good.
is good or bad? It's good. 31's another prime. 31 evenly can't go into 100, so it's just sort of stuck there. Question about the idea, again, if I give you over 100, make a percent. If I give you a percent, put it over 100. But if you're making fractions, you always have to at least think about, if you can, reduce. Anybody confused at all? Here's where we head. In a minute, we're going to do the vocab quiz on all those shapes. So I'll give you a study minute if you want to do that before we do it. You're going to have to name the shape and do the definition. So we'll take a study minute to get ready for that. The homework, once you're done with quiz time, we're going to be working on page 190. On 190, we're just going to do everything. There's a group of letters there that go A to F. And then there's the usual 1 to 25 kind of thing. So 190 is homework. And then maybe we'll do the chart. We'll see if there's time to do the chart. If we have 5 spare minutes, maybe we'll look to do that. Last call, anything? You hit the stop on there. Same button.